Good morning, students. See, all these videos are kept in mechanics playlist. Okay, you should go there and watch these videos. Presently, we are going through this gravitation chapter. So today we will talk about. We will start with gravitational potential. These are very important terms. Okay, yesterday we had a whole narrative of what is actually happening. You have seen this is our globe, and at a particular point you want to find out the gravitational potential energy. We call this point A. So this is our R. What is R? Basically, this distance is R, and let us say this distance is h, and there is a mass m. Okay, here, and this is the mass of the earth. So we R is equal to R plus h, isn't it? R plus h. So the gravitational potential energy was U is equal to minus G m by R, or minus G m by R plus h. While discussing this topic, we also went into a narrative called, let us say there is some mass from infinity. This point is some infinity, very far off from the center of the earth. So from here, slowly I am bringing this to this point in small increments. What will happen if you bring fast? The mass will accelerate. Okay. So you are very small increments of what you are doing, and you are bringing that mass from that infinity to here. Now let us say I bring unit mass. I bring what? I bring unit mass. Unit means 1. I bring 1 unit mass. Okay. So what is the amount of work done? Means that is called gravitational potential at this point. Let us say you are bringing that mass, unit mass, from infinity, very far off distance. Okay, you are bringing that to this particular location. So that work done to bring that unit mass from infinity to this point, because we are calculating here. Okay, if you are bringing it to some other point, the potential will be calculated at that point. This point can be B. So wherever that point we are talking about, that point you are bringing that unit mass from infinity. So that is your gravitational potential at that point. So it is given by the work done by the mass. Okay. So here the mass is 1 actually, basically. Okay. So this work done, what is this work done basically? The work done is this. So gravitational potential is equal to Gmm by R whole divided by m. Okay. See, if I am bringing 10 kilo mass from this point to this point, okay. So for 10 kilos, let us say I spent 120 joules. For unit mass, I will say 120 by 10 kilos, right? This is 1 kilo and 10 kilo. Proportionately we are talking about. Simple language. 10 kilo mass from infinity to the center I brought. Okay? How much work I did? Some vague example. 120 joules I have done. So proportionately 1 kilo mass means 120 by 10, 12 joules of energy is spent. Why we are calculating for 1? Because if you know for 1, you can calculate for 10, you can calculate for 15, you can calculate for 35, you can calculate for 1000 also. Okay? So it's just a mathematical way of simplifying things. So what did I do? The work done 120 by 10. Okay? So here you see m and m cancels. So V of R is equal to minus Gm by R. What is V of R? Potential at a point R distance from the center of the earth. Potential at a point R distance from the center of the earth. If you want to find out, the formula is minus Gm by R. What is G? G is your gravitational constant. Okay, F is equal to Gm1 m2 by R square, that universal constant. Okay, what is that value? 6.67 into 10 to the power of minus 7. Alright, and here that units will come, but value I am talking about. M is the mass of the earth, okay, and R is the distance from the center of the earth. Mass of the earth, it is 6.1 into 10 to the power of 24 kgs. Okay, 24 kg. 6 into 10 to the power of 24 kg. Okay. So, if you want to talk about dimensions, what will be the dimension of the potential? Let us work it out. Yeah. See students, while making these videos, you can see that there is no script here. Whatever that comes impromptu to our mind, we just speak. The idea is to share knowledge. Okay. So some formula error here and there, something. I am also human. I am not a Superman. Okay. All are prone to errors. So any observation you see, you can comment me. You can tell that this formula I have written wrong or something. It can happen by mistake. Some happen unintentionally. Okay. Intentionally nobody wants to make mistakes, right? Isn't it? Alright. See, often they ask you that find the dimensional formula of this potential. Let us say potential, find the dimensional formula. What is the method? We want to find out dimensional formula. Short form I am writing it as DF. See, potential, you have written Gm by R. It is not capital R, okay? It is small r. Small r means distance to the point. But how does it matter? It is, in terms of dimension formula, it is a distance. So, if you know the dimension formula of G, M and R, you can work it out for the V. Here, the negative sign doesn't matter because for dimension formula, negative, positive doesn't matter. Dimension formula will also tell you about the units. Alright. So, you need to know the dimension formula of G. Even I also don't know. What I will do? I will derive. You know that F is equal to Gm1 m2 by R square. Okay, you have to see this as distance. This is mass, okay, this is force, okay, and you are trying to work it out for capital G. What is the dimensional formula? So G is equal to, in rough terms, it is F into some distance square divided by mass square. Understand it like this, okay? Alright, if you know the dimensional formula of force, so dimensional formula of G will be, you can write the dimensional formula of force. What is force? Mass into acceleration. What is the unit? Yeah, Newton is a unit, but what is the fundamental unit? Kg meter per second square. Kg means m, meter means length, per second square, t to the power of minus 2 multiplied by distance square, L square divided by mass square. So m square. This is mass, okay? This is not meter square. So what are you getting here? The dimensional formula of G, you are getting it as m divided by m square. So m to the power of minus 1. L power 1, 2. 1 plus 2, 3. Right? And t to the power of minus 2. So this is the dimensional formula of G. Wait a minute, you have not calculated for V. Okay, so no need to memorize or anything. You can quickly derive. So someone asks you what is the unit of G. So from here you can write the unit of G. All these things I have discussed in the bridge course also. Dimensional formula, how you are writing units and all that. But just, nothing wrong in again discussing. So the unit will be in SI. This is m to the power of minus 1, kg to the power of minus, this is not meter, okay, kg to the power of minus 1 multiplied by L to the power of 3, meter to the power of 3. What is the SI unit of length in length? It is meter. T to the power of minus 2, second to the power of minus 2. This is the unit. In similar way, if they ask you for potential, let us say you know this. So the dimensional formula of V will be equal to G. You have already derived it. You simply write it now. M to the power of minus 1, L to the power of 3, T to the power of minus 2. Multiplied by, what is this? Gm by R. M is mass. So mass means kg. So in dimension, how do you write? Mass means capital M. Okay? Divided by R. R means distance. L to the power of minus 1. Simply add now. See, check the powers. M to the power of minus 1, M to the power of 1. So it will become M to the power of 0 basically. M to the power of 0 means we write dimension in terms of MLT. Even if it is 0, we will write it. Why we will write it? Because everyone writes it. Why we walk to the left of the road? Why not in the center of the road? Because everyone, a same person will walk in the left of the road. It's a standard norm. Okay? M to the power of 0. L to the power of 3, L to the power of minus 1, L to the power of 2, T to the power of minus 2. Okay? What will be the unit? This is not there. So L square, meter square, second to the power of minus 2. Alright? So this is a basic unit. Okay? So this is how you arrive at dimensional formula of any quantity. So basically you should know the formula to arrive at the dimensional formulas. So till now what have we discussed? This is our Earth, Mother Earth, and from infinity you have brought some mass to some point. Now this point cannot be wherever we wish. It has to be under the influence of the gravity. Let us say this is our Earth and our gravitation field. Yesterday I told you there is some imaginary field. In this imaginary field, the object will experience the gravitational force. Okay? The object will experience the gravitational force. Let us say that extent is somewhere here. This is your space. Imagine from space you have brought a mass near this Earth. Near this Earth means not exactly very near to Earth, but to some point. That point must be in the gravitational field. Then only the question of potential will come. Then only the question of potential energy will come. Okay, if you are bringing a unit mass, we said that this point will have some potential. If you bring it to here, it will have some other potential. If you bring it to here, it will have some other potential. Okay, every point doesn't have same potential. Why? Because every point distances are different. Every point distances are different, right? So this potential can be V1, this potential can be V2, this potential can be V3. So every point has a potential. Every point has a potential as long as it is in the influence of the gravitational field. A gravitational field can be calculated. I will tell you how to calculate that. But basically understand, all these are concepts, you need to understand them. Any theory type question may come, whether in NEET or anywhere, you should understand what you are calculating first of all. So, in how many ways we can calculate this potential? Total work done by total mass, that was W by MO. This was one way, and the second was minus Gm by R. So you can say if this is V1, you will write R1. If it is V2, you will write R2. Now mind you, you are calculating from the center of the Earth. You are not calculating from the surface of the Earth. You are calculating from the center of the Earth. So okay, this is one point. Now let me say that you got some unit mass to this particular location. Then you got it to this location. 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 Okay? Alright? So obviously these 4 points will have 4 different potentials. If you club them and see, this is called system. This is called what? System. Okay? This is called a system. So how do you calculate the potential of a system? How do you calculate? What is the way? You have to simply, the potential, the resultant potential of the system will be simply add of this. Okay. So in this system there are 4 locations to which unit mass has been brought from the infinity to those locations. Now why it is brought and all this is none of our business. We have to understand that this point, this point, this point and this point, they are forming a system. In a system there can be 4, there can be 400. But if someone comes and says of this system what is the total potential, the method is to simply add them. Okay, individually calculate them and put, so add them. That is the approach. So this potential is expressed, potential V, units is 1 unit is joules per kg. This is the unit, I am talking about the unit part. Okay, joules per kg is the unit of the potential. Alright, now let us talk some very important point. Till now we have been shouting about this gravitation field and gravitation field. This is your earth. Okay, we are talking about now gravitational field. What is this? Is it something like a football field? No. So this is your earth. Okay, so around this, imagine there is the chalk fell down as usual. Alright, so this is like this. Some in and around the earth there is a influence of the earth. See, it is like this. A local corporator is there, CM is there, PM is there. Alright, he has his own influence. This gentleman has his own influence and this gentleman has his own influence. Whose influence is bigger? No big points for guessing. PM has the biggest influence because he is the PM of the nation. He is CM of the state and he is corporator of a city or whatever, municipality or city or whatever. Okay. So everyone has an influence. So every mass has a field around it. But whose will be the biggest? The biggest mass will have the biggest field around it. Okay, it is also called intensity of gravitational field. We are talking about intensity of gravitational field. Obviously, with common sense, it depends upon the mass. Okay, like in our regular life, see, this is hidden, you know. Influence of a PM means can you physically see it? But you can feel it, right? You cannot see it, but you can feel it. So similarly, now we are trying to find out what is the method to find the gravitational field around a mass. It is not necessarily a earth we are talking about any mass, but in general if you are talking about earth, I want to find the gravitational field at this particular point, which is at some distance, let us say r, from the center of the earth. So how do you find out? Means here, you know, while discussing about potential from infinity, we have got this a unit mass over here. Okay, so imagine that there is a unit mass at this point. There is a unit mass at this particular point which is at r distance from the center of the earth. At this point you have to find between this unit mass and this mass what is the gravitational force. Okay, so gravitational force, how much it will be? It is one method of finding it out. What is the gravitational field? Gravitational field means at this point what is the field strength? Means if you put a unit mass here, what is the gravitational force? What is the gravitational force from with respect to the earth? So how do you find that? So here normally you find g m1 m2 by r square. Alright, r square means here small r square I am writing about. So here this m2 is unit mass and this is mass of the earth, because you are finding gravitational field of the earth. So it becomes gm by r square minus. Okay, so this you indicate by sorry, because we are talking about gravitational field, I will use a term called G. Okay, okay, it is not G, it is E suffix G. Okay, now this gravitational field is a vector. It is a vector. The potential and all that what we discussed, that is a scalar thing. Work done, potential energy, potential, these are all scalar things. They do not have a direction. Direction doesn't matter there. Okay? But gravitational field has a direction. So it is a vector. So how do you find out? One way is finding out like this. So gravitational field, what is the basic definition means? Force divided by the mass. So I can say it like this. I will bring 10 kg from infinity to this point. Okay? 10 kg from infinity to this point. Okay? Now let us say here 10 kg is there. Between this 10 kg and earth I will find the gravitational force. And I will divide by 10. It is equal to saying that I have brought the unit mass. Isn't it? Because proportionately we are talking about. This we have discussed this potential also. Okay? So either you bring unit mass from infinity to this point, okay, and find the gravitational force. That is one way. Or you bring m mass from infinity to this point, calculate the gravitational force, divide by the mass. So these two are the essential definitions of Earth's gravitational field. You can bring this point to this point, you can bring it to this point, you can bring it to this point. Every point will have its own field strength. Field strength. Okay? Different point will have different field strength. Where the field strength will be more means, just think, the closer you are to the earth, the closer you are to the mass, the field strength will be more. The farther you are, it will be less. Why? The question arises why? Mathematically, G is constant, M is constant, divided by distance square. The lesser the distance from the earth, the stronger will be the field. You go more and more distance, the field will reduce. Okay? And you go to such a point that it becomes very, very negligible. Congratulations, you have entered into space. Okay? So, this is the whole thing about this. So the main point is this is your globe, your earth. We are talking about Earth's gravitational field. So what about the direction? Okay. So it is like this. So it is, the direction is marked towards the earth. This is how it is. So the direction of gravitational field is towards the earth when you talk about gravitation, Earth's gravitational field. So these are called field lines. Now let me tell you that these field lines are just imaginary lines. So if you take a mass, okay, and you just construct these lines. Okay, these are field lines. There is a purpose why I am drawing all these lines. What is happening? You carefully observe. Closer to the earth, let us say this gola is earth. Closer to the earth, these lines are very, very tightly packed. But when you go distance, what is happening? Their distances are increasing, you know. The distances between the lines are increasing. So the closer the line, the stronger the field. Closer the lines, stronger the field. Farther the lines, weaker the field. So if you go at a very, very far off place, the field is negligible because one line is going like this, another line is going like this. But when you come to very, very close to the big mass, what will happen? The lines will become closer and closer. So the intensity of Earth's gravitational field increases closer to the Earth. Okay? So that is why when you bring a mass, it falls towards the Earth. So if there is a mass here, the mass doesn't fall off like this, it is fall towards the Earth. So practical purpose we say it is vertically down. Okay, now why it is vertically down, that is another story to tell you, but here the main point is when you bring a mass into the Earth's gravitational field, it will experience gravity. Okay, and how strong it will feel the Earth's gravity will depend upon the Eg value. Okay, so this is the whole concept behind gravitational field. Okay, for different type of cases will be calculating this gravitational field. So this is one point we have discussed. So here formula wise, some confusion always comes in terms of field and the potential. Just look at those formulas what we have written. So potential was Gm by R, and what was Earth's gravitational field? It was Gm by R square. Note this difference, okay? They sound very silly, but this is a vector, this is a scalar, okay? So if you take your Earth, so at this point, let us say particular point, there will be some particular potential definitely if it is in the Earth's gravitational field. So there will be a field strength also. So that field strength also we can work out. So the method we have discussed. So in the yesterday's class and today's class we have talked about potential, and we have talked about gravitational field. Today we have seen how to calculate the gravitational field at a point. Okay, and then yesterday class we have talked about potential at a point. So note the difference, they are two totally different things. Many questions are asked on that. At this stage you should know the formula. Okay, this is potential. From potential you can work out the potential energy. From field strength you can find the gravitational force. From this you can work out force, which is gravitational force. From this you can work out the potential energy. Okay.